Putin has now effectively unleashed a 13,800-ton nuclear-powered submarine monster, a next-generation attack boat designed to carry a heavy load of advanced cruise and hypersonic missiles deep beneath the ocean surface. This new platform gives Russia the ability to fire Zircon and Kalibr missiles from depths approaching 600 meters, turning the seabed into a concealed launch pad and dramatically expanding the reach and survivability of its naval strike capabilities. The Ulyanovsk has now entered the water as Russia's latest silent nuclear killer, a Project 885M Yasen M class submarine that has just been floated out from the Sevmash shipyard and moved into final fitting out before joining the fleet. Russia's Project 885M monster is officially afloat at a time when much of American attention is already focused on submarine warfare, adding yet another sophisticated hull to Moscow's undersea arsenal and complicating Western naval planning. Russia has dropped this nuclear-powered killer sub into the ocean armed for war, equipping it with vertical launch cells for Kalibr, Zircon, and other cruise missiles, as well as torpedo tubes, ensuring it can threaten targets on land and at sea from far offshore. Amid its ongoing war with Ukraine, Russia has launched a new nuclear-powered submarine, adding another advanced undersea platform to its fleet at a time of heightened tension and military confrontation. The Ulyanovsk is reported by defense outlet Militani to be capable of carrying Kalibr cruise missiles, giving it the ability to strike land and sea targets at long range with precision weapons from beneath the waves. This submarine was officially launched at the Sevmash shipyard in Severodvinsk on July 28, during a ceremony attended by senior Russian officials and naval commanders, marking its transition from construction to the fitting-out phase. Following the launch, the Ulyanovsk was moved out of the construction hall and into the shipyard's waterside facility, where it will remain moored while crews and engineers continue installing systems and preparing it for trials. Final outfitting work on the nuclear-powered submarine will continue at the pier, a process that typically involves extensive testing of weapons, sensors, propulsion, and crew accommodations before the vessel can head to sea. Once harbor trials and subsequent sea trials are completed, the Ulyanovsk is expected to enter operational service with Russia's Northern Fleet, bolstering the Navy's long-range strike and undersea warfare capabilities in the Arctic and North Atlantic. Current plans call for the submarine's formal transfer to the Russian Navy to be concluded by December 2027, giving Sevmash roughly a year and a half after launch to finish all testing, certification, and crew training. The Ulyanovsk is described as the 9th submarine in its series, with 2 additional boats of the same Project 885M line already in the early stages of construction, reflecting Russia's long-term investment in this class of multi-role nuclear attack submarines. At present, 4 Project 885M submarines are reported to be in active service with the Russian Navy, operating alongside earlier Yasen-class boats and forming a growing core of the country's modern cruise missile submarine force. A 5th submarine in the series, named Perm, is undergoing trials that are expected to be completed by the end of 2026, after which it too will likely be commissioned and added to the fleet. Perm is expected to become the first submarine of its class to be armed specifically with Zircon hypersonic missiles, making it a flagship platform for Russia's newest sea-launched strike weapon and significantly enhancing the Navy's ability to threaten distant targets. Russia's Project 885M submarines measure about 130 meters in length and 13 meters in width, giving them a sizable hull form that supports extensive internal weapon bays, crew spaces, and advanced sensor suites. When fully submerged, these boats displace roughly 13,800 tons of water, underscoring their status as heavy, ocean-going nuclear attack submarines built for long-range operations far from home ports. Their propulsion system is centered on a single OK-650V pressurized water nuclear reactor, which generates the power needed to drive a high-output electric motor and provides effectively unlimited range constrained mainly by crew endurance and supplies. In service, these submarines can reach a maximum submerged speed of up to 31 knots and a surface speed of about 16 knots, allowing them to maneuver quickly underwater while still maintaining respectable performance on the surface. The class is rated for a maximum diving depth of 600 meters, with an operational depth of around 520 meters, enabling the boats to operate deep below the surface where detection becomes significantly more difficult. Endurance for Project 885M submarines is limited to approximately 100 days at sea, meaning they can conduct extended patrols and missions without resupply, particularly in remote regions such as the Arctic. Their main armament consists of 10 SM-346 vertical launch systems, each capable of housing multiple Kalibr, Onyx, or Zircon missiles, giving the submarines a substantial salvo capacity for land attack and anti-ship strikes. 4 torpedo engagements. The boats are equipped with 10 533mm torpedo tubes, which can launch heavyweight torpedoes, anti-submarine weapons, and potentially naval mines against underwater and surface targets. They also feature launchers designed for deploying specialized torpedo decoys, enhancing their survivability by confusing or seducing incoming enemy torpedoes away from the hull. The submarine's hull is constructed from low magnetic steel and coated with rubber cladding to reduce acoustic signatures, a combination intended to minimize noise and make these platforms extremely difficult to detect with standard sonar. Even as China and Russia keep expanding their missile arsenals and air power capabilities, the United States is increasingly shifting its focus toward reshaping strategy, industrial capacity, and alliance networks rather than simply matching them system for system. The U.S. Navy is now moving toward a new era of submarine air defense as missile threats grow faster, deadlier, and harder to intercept. According to the War Zone, the U.S. Navy is pursuing a new submarine-launched anti-air missile, opening a capability it has never fielded operationally before. That capability is part of the Next Generation Naval Modular Missile, or NMM program, which is designed to modernize the Navy's surface and undersea launch options. The program aims to create one common interceptor that can underpin multiple naval air defense missile variants, simplifying future development and deployment. Per the U.S. Navy, the modular design could boost firepower while cutting logistics complexity, making the system easier to produce, move, and sustain. If fielded, the program would give U.S. submarines a true surface-to-air missile capability for the first time in Navy history. The NMM is built around one common terminal stage interceptor, or TSI, which serves as the core of the entire family. Its modular design supports multiple missile variants, allowing one base weapon to be adapted for different naval roles. The missile family is intended for both surface ships and submarines, giving the Navy a shared interceptor architecture across platforms. Open architecture is meant to allow future upgrades, so new sensors, seekers, or software can be added later. The system is designed for both defensive and offensive missions, making it a flexible tool for future naval warfare. The Navy wants production to reach 1,000 interceptors annually within 5 years, showing how ambitious the scale of the program is. The Navy envisions 4 different missile variants built around the same interceptor core, turning one design into several battlefield roles. Long-range, dual-pack, quad-pack, and submarine versions are all under development, giving the program a broad future footprint. The long-range version is designed to fit existing Mk-41 vertical launch systems, so it can slot into current Navy warships. Let's take a look at the types of NMM variants. The LR variant is meant for single loading inside each Mk-41 VLS cell, maximizing compatibility with existing launch systems. The DPER is an extended range version designed for dual packing, allowing 2 missiles to fit where one normally would. The QPMR is a medium-range version designed for quad packing, creating even greater launcher density. The ERS is an extended-range missile intended for submarines, making it the version most closely tied to undersea launch. Both the LR and ERS variants are expected to reach hypersonic speeds, pushing the design into a far more advanced performance category. The most unusual version is being designed for Virginia-class attack submarines, according to the War Zone. That missile would use 7-cell canisters inside the large Virginia payload tubes, making the submarine a hidden missile launcher. Block V Virginia-class submarines are set to receive these payload modules first, putting them at the front of the deployment line. One reason to arm submarines this way is to defend against anti-submarine aircraft and helicopters that hunt beneath the surface. They could also support carrier groups as hidden air defense platforms, adding protection without revealing their position. The system could help destroy enemy AEW and C and surveillance aircraft, removing the eyes and ears of the opposing force. Using network targeting data, submarines could intercept incoming missiles from unexpected angles. They could conduct surprise long-range air defense from concealed positions, creating a new layer of uncertainty for any attacker. The submarines could also carry mixed loads alongside Tomahawk and hypersonic missiles, expanding their strike and defense options at the same time. The new missiles are expected to counter advanced supersonic and hypersonic threats, which are becoming central to modern naval warfare. The U.S. Navy says recent wars have highlighted the need for larger missile magazines, because high-intensity conflicts burn through interceptors quickly. Higher missile capacity could reduce the need for frequent combat rearming at ports, helping ships stay in the fight longer. The modular design may also speed up production during future high-intensity conflicts, when speed and scale matter most. The Navy wants a highly agile multi-mission interceptor that can switch between different naval threats quickly. It is meant to defeat aircraft, cruise missiles, and hypersonic missiles, all with the same basic weapon family. It must remain compatible with existing U.S. naval launch systems, so it can be fielded without a total fleet redesign. The design also calls for modular components from multiple manufacturers, widening the industrial base that can support production. Scalable production for wartime demand is another priority, because the Navy wants inventory that can expand fast if war breaks out. Ultimately, the goal is faster, cheaper, and more sustainable missile inventories that can survive a long war of attrition. The Navy says the new missile family would help outpace rapidly evolving threats, rather than constantly reacting after the fact. The effort follows stockpile pressure from Middle East crises and aid to Ukraine, both of which have tested U.S. missile inventories hard.